So the big picture for this lesson is modeling quadratic functions. And there's kind of a lot packed into this lesson. Let me just take it one piece at a time. The first topic is using points to determine a function. So if you have a quadratic function in vertex form and you're given the vertex, you only need one other point to make the function. So for example, let's say I have the vertex is 1, 4. I can put that in here. Like that. So now to make the function, I just need to solve for this a value, this unknown coefficient. But if I have a coordinate, like say I have the coordinate 2 and then 9, I can substitute the 2 for x, the 9 for the output f of x, and then I can solve for a. So when you're solving for a quadratic function in vertex form, if you know the vertex and one point, you can write the equation. Now if you're given something like this in factored form, and you're provided the two x-intercepts, you still need one other point. So let's say I know the x-intercepts are -3, 0, and let's go with 3, 0. I substitute those values in for the p and the q, the -3 and the 3, you get f of x equals a, and then x minus -3, and then times x minus, well, just the 3, that's the positive 3 in there. That equals f of x equals a times x plus 3 times x minus 3. So then you need one other point to solve for this a value. So if you're given the point, say, 0, 12, you could put the 0 for the x and the 12 for the y, and that would have you solve the a value, and then you would have your function. So if you're given the vertex, you need 1 point. If you're given the two x-intercepts, you need 1 point. And then you can determine the function that fits those points. So what about if you have some data and you're not just given a couple of coordinates? Well, one way to look at it is you can look at the first differences and second differences. This is right out of the lesson. So here's a linear model, and you can see the x and y coordinates. Now if you subtract the y values and the difference is constant between each x value, you'll get the same number. And that's because the slope is constant for a linear function. So the slope here is 3. And that first difference is 3 each time. For a quadratic model, the first differences are different, but the second differences should all be the same. In this case, the second differences are all 2. So to do second differences, you do the first differences. So 4 minus 9 is -5, 1 minus 4 is -3, and you continue on that way. Then you do the differences again. -3 minus -5 is 2, -1 minus -3 is 2, and you continue on. So the second differences are all 2. So that's a way to determine if a quadratic model could fit the data, as you do the second differences. Now the lesson's also going to show you, using a calculator, you can enter in the data points, and then you can use the calculator to determine an equation of best fit. There's a video in the lesson that shows you that. So that's the big picture for this lesson, modeling quadratic functions.